Morning, everyone, and great to be part of this community and presenting to you guys this morning. So my talk is in a slightly different perspective and from slightly different sector, focusing on automotive industry and transport. So I'm from Advanced Propulsion Center. APC is a funding body and a supporting organization sitting between automotive industry and UK government, supporting decarbonisation and the sector's journey, automotive sector's journey towards net zero. This is the work we've done over the past kind of 10, 12 months now. And the purpose of that was how we define a clearer scope to support digitalisation as part of our funding streams. So we started with looking into what's happening across the globe in terms of including digitalization in net zero plans and in net zero activities. So we have seen that major economies committing to net zero, they are leveraging digitalization as an intrinsic part of their transformation journey. And we have seen the shift to electric mobility and digitalization, how it has increased the competition from likes of US and China. In US, we have recently seen Inflation Reduction Act and CHIPS Act, which both of them place a significant advantage to US in terms of green technology economy, and digitalization capabilities and digitalization technologies are prioritized to capture the efficiency and the innovation improvements targeted by these two legislations. EU Green Deal, which is kind of a counteract to IRA, to Inflation Reduction Act and CHIPS Acts from US, and the newly published Critical Raw Materials Act from Europe. Again, it supports strategic technologies in net zero materials manufacturing for net zero technologies and products. And again, in EU Green Deal, we have seen a significant kind of emphasis on digital technologies and digitalization as part of that. In Germany, again, automotive sector is the most innovative sector, accounting for almost 34% of total industry R&D expenditure, almost 71 billion euros of spend going into automotive R&D in Germany. And again, they are putting a lot of focus on electric mobility and digitalization at the same time for production and design of those electric mobility solutions. In China and in Japan, we have seen a similar story. Then what is happening in the UK and what's the status in the UK? We have seen that we've got a kind of the landscape in the UK is we've got a very and very capable digital community. UK is placed the fifth nation across the globe in terms of having the world's top R&D investing companies in digital technologies. We've made a smarter program as the UK flagship program to support digitalization for UK manufacturing sector, but the opportunity to trickle down the value add from likes of Made It Smarter and from this capable UK digital tech network to automotive industry, to automotive design manufacturing hasn't been harnessed properly yet. And there is an opportunity for that. And that's why we have decided to develop this framework. We've looked at some of the digitalization trends in EVs across the globe again, and we've come up with this kind of definition. We've seen this definition of non-native EVs and native EVs. And when you compare and contrast the two sides, you can see that 15 to 20% efficiency improvement in cost and time to market from likes of Tesla, from likes of BYD, from likes of those car manufacturers, electric vehicle manufacturers who put digitalization first before setting up their manufacturing line and production process, whereas likes of other OEMs who have been active in ICE manufacturing process, they're now trying to rejig and readapt their manufacturing process to put more digitalization in place, and they lag behind because of that. They are kind of they are the definition of the non-native electric vehicle manufacturers. So that's what we have seen from this McKinsey report. because of that, we decided to create this digitalization framework to articulate the value adds in terms of productivity and sustainability for automotive industry, looking at subsystem, vehicle system, and ecosystem level kind of value adds across the board for design, test, launch, for manufacturing and supply chain connectivity and supply chain improvement, and to meet all of those tough regulations around sustainability, recyclability, and life cycle impact analysis. So this is basically the scope we defined for our framework. How it works and how we put it into that framework. So we started with looking into the 5 main stages along the vehicle system and subsystem life cycle, from concept definition, where we have initial concept and material selection, and basically how we develop the concept based on specific use case and requirements and environmental consideration. And then we move to the design and engineering side of that, and then we come up with potential optimization throughout that process. Then we move to the production and manufacturing, and that involves pre-production and prototyping, as well as physical testing and validation of that engineering design. Then that vehicle or subsystem, and by subsystem, by the way, I mean something like a battery pack or a electric motor or a hydrogen fuel cell, for example. So what is happening to that vehicle system or the subsystem in service? What is the operational condition of that subsystem? What's the use case? What's the regular maintenance requirements, and to keep it in a proper working condition? And then at the end of the life, what's going to happen to that vehicle system or subsystem? Is it going to be disassembled and recycled and shredded, and we take the valuable materials out of that, or it's going to be reused in the second application? So we basically looked at the entire kind of life cycle for a vehicle system and subsystem, and then we started with a system engineering V model, which you are all familiar with. I'm sure you've seen it in different sectors, aerospace using it, automotive using it, all of the manufacturing based industry using this V system model, which is about design and delivery from concept definition to end of life. And it does have a number of kind of stages, but that's mostly on the physical side. So how we complemented with digitalization technologies to make it more advanced, we put the virtual model of the physical V model, V system model, on top of the framework, and said that digital technologies should cover across the board at every stage of the vehicle life cycle or subsystem life cycle, by adding modeling, simulation, and digital twin to that stage. And it goes across the board from defining the needs and requirements for that vehicle or for that solution to the final solution delivery to the market. So this is called model-based system engineering, and I'm sure again you've seen a similar model like this in aerospace sector, for example. What it means again in more details. So in terms of those digital technologies I just covered, in terms of those modeling, simulation, the virtual side of this MBSE framework, we have a number of technologies, digital technologies covering that, from enabling technologies to process technologies to co-creation technologies. Enabling technologies helps us to design and helps us to improve the efficiency and optimize the design stage. Digital processes, it mostly focuses on the connectivity on the shop floor or connectivity across the supply chain, and facilitate the virtual certification and testing and simulate that testing and validation. And then co-creation technologies, against enabling and facilitating supply chain interactions across the board. So this is basically the sort of digital technologies we have listed as part of this framework, and we put them against enabling, process, and co-creation technologies. For those of you who are familiar with the IDE roadmap, Institute of Digital Engineering roadmap, which was published in 2021, this is very much aligned with that very high-level roadmap. this framework, and the way we have categorized these digital technologies in terms of enabling technologies or process technologies or co-creation technologies. But again, for a company to use this framework, they need to define where they sit in terms of digital maturity, what level of digital maturity they have, and what level they want to get to. And we've defined these the 5 levels based on the type of companies we have interacted with, and based on the overall kind of situation and status of a company. So whether it's base level connectivity they are looking for, or they are looking to advance it a little bit more and have a data framework there, or add a little bit more advanced digital technologies to that to have feedback and feed forward and improve their processes based on that. Or have, again, more advanced version of that and having a modeling and digital twin integrated into that. Or finally, having a very transparent and traceable and secure kind of protocols across the board with all of their suppliers and with all of their customers. So understanding your digital maturity, I will...
Last 30 seconds, that's okay.
Yeah, of course, yeah. So it's important for any company who wants to use this framework and who wants to get into this world of digital and digitalization to understand their capability first and define it first for themselves and define their target level. And we've basically tried to facilitate that by giving this definition. I'm going to skip these 2 case studies from APC and just go to my conclusion slide, which is basically this digitalization value adds from using digital solutions and digitalization. You could articulate it, and you could justify that by having this framework as your kind of guidance when you applied for APC funding. And we would like to see more digitalization focused and digitalization based projects coming to our pipeline. So please get in touch if you would be interested in this. I will, and I can share these slides, and there is a version of these slides on our website.
So Hadi, how are you measuring improved efficiencies through the life cycle enabled by your framework?
Well, it depends on which stage of the life cycle you're looking at, and there are some KPIs defined for each for each stage, which I didn't have time to go through details of that. I think looking at the framework, first thing you need to decide which level of digital maturity you are at and which level you want to get to. Based on that, you can use the framework to have some guidance on how you measure it yourself and how to present your proposal for funding.
Very good, thank you. And our last question, Hadi, if I may, is what do you foresee as the requirements for the end of life requirements for tracking and sharing digital twins of batteries and their components?
That's a very good question, and I can talk about this for at least an hour. But the thing is, we have seen this new EU battery regulations, and there is a great emphasis on the end of life because of the critical materials which is going into battery production. It's important to understand that it's currently not a cost-effective process, and it's not a cost-effective agenda in place for battery recycling, but it's mostly driven by regulation. I think in the longer term, it has to become cost effective, and that's what we are trying to fund, and we are trying to see more innovation R&D at. I'm more than happy to pick this up in more details. I think digital twins and digital technologies have a great potential and have a great capability to enable that and to make it a cost-effective process.